Good afternoon, everyone. My name is Joseph Oakes. I'm the superintendent at the Eastern Virginia Agricultural Research and Extension Center here in Warsaw. I'd like to give you an update on a project that we've been working on the past couple of years here at the station and at other ARECs as well, trying to use proximal sensing to determine tiller density and nitrogen timing in winter wheat. This is an update to what we discussed in our virtual small grain field day. If you would like to see that, you can go on our Facebook or YouTube pages and find that video. So just a little bit of background. The decision of whether to apply nitrogen at growth stage 25 is often based on the number of tillers present. If you have more than 50 tillers per square foot, you often do not need to apply nitrogen at growth stage 25. If you have less than 50 tillers per square foot, you need to go ahead and apply some nitrogen to sustain you until growth stage 30. However, how many of you are going to go out and count tillers? It's a very laborious process. As you see in the picture here in the bottom right hand corner, you have to take a yardstick, go out and count the number of tillers per square foot. There's also field variability involved. There's a lot of time involved. So a lot of times this method is underutilized by growers due to these factors. Well, this project we're looking at here is a project where we've been looking at the past few years, trying to determine whether or not sensors that are mounted on drones can give us an adequate representation of tiller density and crop nutrition status. A project done in Virginia in the early 2000s looked at over 20 site years and determined that NDVI, normalized differential vegetative index, collected from the ground, provided a very good representation of tiller density. So we'd like to use this project to determine if we can collect NDVI or other indices from the air with a drone to determine how well it represents tiller density. So to do this, we set out a series of 12 treatments. We've done this for the past 3 years with different nitrogen rates and timings to determine the relationship between aerial indices and tiller density. As you see here in the chart, we have 12 different treatments with varying nitrogen rates applied at December 1st, growth stage 25, and growth stage 30. This past year, we put out a second set of plots that have received no nitrogen and 30 pounds of nitrogen in December. Then the remaining nitrogen at growth stage 25 was applied based on 3 different methods. 1, the tiller density method, 2, based on NDVI, and 3, based on NDRE, which is normalized differential red edge, based on a different band in your multispectral camera. Growth stage 30 applications were then made to bring to a total of 120 pounds of nitrogen after planting. So how do we determine what NDVI and NDRE values we needed? Well, based on our charts that we've generated the past 3 to 4 years, the relationships between aerial indices and NDVI, plots with an NDVI of 0.6 or higher corresponded to 50 tillers or more. So these plots received no nitrogen. Plots with an NDVI of 0.49 to 0.6 received 40 pounds of nitrogen, and plots with an NDVI 0.38 to 0.49 received 50 pounds of nitrogen. And we did this same process for NDRE as well. So in order to collect our data, you see us out here collecting tiller density. We also collected handheld NDVI with our green seeker, as you see right here. This is our multispectral MicaSense red edge sensor, which is mounted onto our drone here that we flew over our plots to collect our aerial data with. Now, let's look at data the past 2 years here in Warsaw at the Eastern Virginia AREC in 2019 and 2020. You see in 2019, these orange lines here is aerial NDVI relationship with tiller density, have an R squared of 0.75, which is fairly good. Ground NDVI was 0.86, while aerial NDRE was only 0.52. Not quite as good relationship, but we made some changes this year to help us achieve a better relationship between our tiller density and our different indices. First thing we did was, instead of collecting data collecting tiller data at only one spot per plot, we collected at two. So our NDVI and NDRE represented more of the entire plot than just that one spot did. So this data was collected starting in early December all the way up to growth stage 30. And you see very good relationships with our aerial NDVI and tiller density. R squared almost 1-to-1 is 0.9. We see the same thing with ground NDVI here in the gray. Another very good R squared of 0.83. Our aerial NDVI was not quite as good at 0.76, but it was still significant with a P of 0.05. So now let's look at how we saw we had good relationships between our aerial indices and tiller density. Now let's see how it corresponded when we applied nitrogen based on those aerial indices. So we're going to look at the plots that received no nitrogen in December. When we counted tillers at growth stage 25, it indicated we needed to apply 50 pounds of nitrogen. We collected our NDVI, it also indicated we need to apply 50 pounds of nitrogen. And same with our NDRE, they all indicated we need to apply 50 pounds of nitrogen. Now let's look at the plots that received 30 pounds of nitrogen in December. We counted tillers based on the number of tillers per square foot, indicated we need to apply 40 pounds of nitrogen at growth stage 25. NDRE and NDVI both also indicated that we need to apply 40 pounds of nitrogen at growth stage 25. So we see that for plots that received no nitrogen in December and 30 pounds of nitrogen in December, all three methods, the traditional tiller method and using the two indices from the drone, they both indicated that they all three indicated that the same amount of nitrogen was needed. This is very, very good because this shows us our relationships were good and the data we're getting from the drone is comparable to what we're getting from the traditional tiller density method. Now let's look at grain yield. We see that no difference in yield was whether N was applied based on tiller density, NDVI, or NDRE. Let's look at this chart here. The first three lines you see here is when there was no nitrogen applied in December. You see there's no difference in yield whether we applied nitrogen based on tiller density, NDVI, or NDRE. The same with the next three. Plots that received 30 pounds of nitrogen in December, there was still no difference in yield whether we applied nitrogen based on tiller density, NDVI, and NDRE. This makes sense because all three methods, they indicated that we needed to apply the same amount of nitrogen. Now, to wrap up what we found this year, three conclusions. Number one, aerial indices produced from a multi-spectral sensor attached to a drone, they accurately determine tiller density in winter wheat. We've seen very good relationships, significant relationships the past 2 years. Number two, there was no difference in grain yield if growth stage 25 nitrogen was applied based on tiller density, aerial NDVI, or aerial NDRE. And number three, we will continue to do this the next couple of years to continue to validate this data to ensure that these methods all produce the same amount of yield and indicate we need to apply the same amount of nitrogen. With that, I'd like to thank several funding agencies that funded this research. Number one, the Delmarva Land Grant Cooperative Seed Grant Program. Also like to thank the Virginia Small Grains Board. I'd like to recognize the Virginia Tech Smart Farm Innovation Network, which this project is part of. I also like to thank our co-authors, Dr. Maria Belota, Dr. Wade Thomason, Dr. Bryce Kaznavi. And if you have any questions, our contact information is below. Thank you very much.